Okay, hello. I'm going to show you the puzzles that I take when I do a careers fair stall. My tactic at these is to set up a lot of puzzles, because basically a careers fair has a lot of stalls from employers, and they are generally people in suits who have a serious message about what it's like to work at this company or that company, and I'm definitely not trying to employ people, and I want the students to be aware that I'm a bit different, so I try not to do that whole very serious thing. And what I try and do is, I think these fairs can be quite grueling, and I try and do a bit of fun combined with some careers advice leaflets, and that's my strategy. It seems to work very well. People sort of come for a breakout session, play with the puzzles, and then go back to the main conference. So I have them laid out on the table here, and I'm going to pick you up and show you what's what. Okay. Right. So let's start with this one. So this is very simple. This is an orthogonal Latin square. So this is from a pack of cards that came out of a cracker, which are very small. If you look at my hand against them, that's because they fit in my bag easier. That's why I use those. No reason you couldn't use a normal sized pack. And the idea is to arrange this 4x4 grid, or if you wanted to make it easier, you could take the jacks out and make it a 3x3 grid, so that each suit and each card value is represented in each row and column. So there's only one queen in each row and column, and so there's only one heart in each row and column. Okay. Above that, right, we have this game. Now this is basically a big circle. It's got an IMA logo at the bottom and some instructions at the top. The instructions say 3 lines dissect a circle, making 7 regions. And what it's asking you to do is put 1 snowflake in one region, 2 in the next, 3 in the next, 4, 5, 6, 7. Probably 6, 7 actually. Now the game is, there are 3 coloured lines, and the game is to arrange each of these, in this case little snowflakes, which are they're like for making Christmas cards out of or something. In the original puzzle they were ants, but I didn't have ants, so I've used snowflakes. The game is to arrange it so that if you look at this green line here, so that there are an equal number of snowflakes this side of the line as there are this side of the line, but to do that for all 3 lines simultaneously. And I think this is I guess one of the more difficult puzzles. People play around with it. People usually come to a solution. There are actually, there are 3 that I know of, which are here. I can send you this if you need it. A good starting point if people are getting stuck is to point out that the solutions have 1, 2 or 4 snowflakes or ants in the middle. So if people are getting stuck, you can look at it, and some people will have put a different number in the middle, and you can tell them, well, look, there's no way that's going to work. I happen to know, and that sort of gets them started. Right, moving this way. This is a very homemade little puzzle. You could make it better than this, I'm sure. Basically, these are coins. What I do is I say to students, right, so the best way of packing objects into a space is to tessellate them, right? So you do this so that the objects tessellate. And the students will generally say yes, because they've been taught that the best way to pack a space is to tessellate. So I say, well, look, by tessellating we fit 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now I fit 9. And you can't fit the 9th one if you stack them back up again. You know, the 9th one doesn't fit there in the way that you would expect. So what's going on here? This tends to confuse them. What's going on here is that the best way to pack a space is to tessellate the objects if you have control over the size of the space. So if you have an infinite space in which to work, for example. Now, they often don't think about that, basically. It's sort of interesting. Anyway, and then the puzzle here is you say to them, well, now fit in the 10th one. Okay, and it is possible. Now, there's a slight issue with this. This box, I think you can probably see, is just a few bits of wood screwed together with a bit of MDF in the middle. I made it. There's a formula, which I could look up for you, of how to make this work, but basically the size of the box has to be some multiple of the size of the circle, which in this case I'm using a 2p piece, and then you can fit them in roughly. Now then, hold on. 1, 2, 3, 4. Trying to remember precisely how it works. There we are. So there I fit 10. Okay, into this space. Now that was slightly easier than it should be, because when I've sawed these pieces of wood I've got about 1 millimetre wrong, unfortunately. So but it works fine as a demonstration. They usually find that fairly quickly by trial and error, and then you point out that part of this is stacked in a very regular way. That one is, and then the rest of it is tessellated. So it's a kind of combination of the two. And the book I got this out of had an example with 100 circles. And the only way to stack that, as far as I remember, is to have the first 3 rows as being like this, in line, and then the rest of it tessellated. And it wouldn't fit if you tried to tessellate it all the way. I think that's very interesting. I have one of these sliding puzzles. These cost money, of course. These where you arrange the pattern into the things into a certain pattern. The problem with this one is that it's a Braille one, and I can't remember what it used to say, so it's a bit difficult to work out. The reason I have that is because I have a talk where I talk about the 1415 puzzle, which you can look up if you don't know. I have a Rubik's Cube for similar reasons. That usually makes people obsess slightly. Usually someone knows how to solve it, and then they end up teaching everyone else how to solve it, and it's kind of quite a nice thing. If you do find someone who knows how to solve it, I also have a Sudoku one, which is harder, I think. I thought in some ways it might be easier because you've got a clue from the orientation of the numbers, but actually, just because it's that way around, it could be on any of these 4 sides, probably. I don't know. Anyway, there we are. I have some other bought sets of puzzles. So I have this box here, Brain Benders, it says. I think this came from Debenhams, which has stuff in it like this, which is a series of bits that you sort of locked together. I'm not so keen on these type of puzzles because they have, basically the point ends up being that you have to force them a bit to get them to squeeze together, and I don't like that as a mathematical solution, really. But at the same time, it really draws people in because it's a nice 3D tactile thing that people can start fiddling with. So I have a few of those. You can see on the box there are several different ones. I have this.